So I'm going to start into the locks this week, and what I wanted to show you was the type of safeties I'm going to incorporate into this lock. And basically what I'm going to do is, this is a picture off of Hallowell & Company's glossaries and definitions page, and this is a picture of a side lock with an intercepting sear. This is the regular sear down here where it engages the tumbler, and then up here this is an intercepting sear that intercepts, hence the name, the part of the hammer on an internal hammer like this. What I'm going to do is I'm going to take this basic design and I'm going to modify the L&R locks to use this intercepting sear idea. And then there's another feature I'm going to put on the L&R lock, and you can see this has a nice dolphin shape to it, this lock here. But it has something else that's a real nice safety feature. This piece on the inside here, as you see it, this is called a stocking safety. On the outside it's got a little flat or knob that allows you to push it in or out, and it actually engages the hammer itself on the outside. There'll be a notch in the bottom side of the hammer in between the plate and the hammer itself, and this safety here will actually physically engage the hammer and keep it from rotating. So this is a back action lock similar to what I'm going to use, but it doesn't have the intercepting sear. It has a single sear. So what I'm going to do is I'm going to incorporate a stocking safety into it and the intercepting sear to intercept the tumbler. And so I'm going to show you how that's done, and I'll do a little drawing to show you how it looks on paper with the type of modifications I'm going to make, and then I'll get started on building them. So what I've got here is I've got the left-hand lock, which is all still fully assembled mostly. And then I've got the right-hand lock, which is almost completely taken apart. All that's left on here is the tumbler and the bridle right at the minute. And then I've got the lock template that I'm going to use to reshape these. I want to show you the template first, how I'm going to change the body style of these straight locks to a knife dolphin shape. And so the way that's going to work is, I've used this template for a lot of other guns, and so it's got a long piece of tab up here on front which allows me to shape it any way I want to tie into the action, and then it's a little longer in the body section here that allows it to flow better into the pistol grip section. And then the rest of it is just a matter of it fits so that it will cover all the internals of a standard L&R lock. So basically I get to use all the internals of a regular L&R lock, and I'm just going to replace the lock plate on the outside to give it that nice dolphin shape and get the right contour to match the grip and tie into the action. So now I'm going to talk to you about how I'm going to modify the safeties to give it an intercepting sear and a stocking safety. On a standard L&R lock, they only have one safety built into them, and what that is that's a half-cock notch right there. And so that notch, you can't pull the sear through it unless you're really trying. It is possible to break them and break through the sear through a half-cock notch on just about any style lock that has a half-cock, but for the most part, I mean, you can't really push the sear through it. And then it goes to a full-cock position. And so that's the only safety on a standard L&R lock, and that's on most muzzle loaders and stuff. That's pretty much the traditional safety on them is a half-cock notch, and that's all you get. But since this is a cartridge gun and it's a double rifle, and this one happens to be extremely big and going to have considerable amounts of recoil, I want to build some other safety features into it, like that intercepting sear that I talked about and the stocking safety. To do the intercepting sear is I'm going to take and I'm going to machine a hole that runs right along where the tumbler sticks through the bridle here. And then I'm going to put a leg out of this tumbler that'll go clear through the bridle. And the way it'll work is just like that picture I showed you, where there's a leg that sticks out from the hammer on that picture. There'll be a leg sticking out of the tumbler on this. And then there'll be a intercepting sear that runs up here and catches the front edge of that bar sticking out. So that in the event of recoil dislodging the first sear, that bar will engage and catch the tumbler itself and prevent it from rolling down with recoil. The only way to make it actually clear and fire would be to have it on full cock and to be able to actually work both sears up at the same time. That way no amount of jarring or jostling or recoil will knock the first sear loose and allow the hammer to drop. It takes both sears moving in concert to release both catches at the same time. So that's the idea of an intercepting sear, is that even if your primary sear fails, the intercepting sear will catch the tumbler or catch the lock, the hammer in that other picture, and prevent it from rotating any farther forward. And so that's how I'm going to do this one. Is there'll be a leg that comes off the tumbler and penetrates right through the bridle, and there'll be an intercepting sear that intercepts that leg and prevents it from rotating forward. So here's an exaggerated drawing of the tumbler and the sear spring. The main spring would be hooked up to this stirrup here. And so basically, same piece right here. Got the tumbler shaft, half cock, full cock, and the stirrup. And that's what I've got drawn here, half cock, full cock, and the stirrup. So what I'm going to do to make an intercepting sear out of this is I'm going to add a piece of material up here to the top of the tumbler. And if you were looking at this from the top down, what you would see is you'd see a piece like this that had the axle sticking out of it, and then it'd come back to, this, and you'd have your stirrup piece sticking through here and up like so. And so what I'm going to do is I'm going to add a piece to this that sticks out through the bridle like so. And that'll give me a piece sticking out the top of it here, so that when I add the and of course this isn't drawn to exactly dimensionally how this is going to be, it's just to give you an idea of the second armature of the intercepting sear. And so there'll be an intercepting sear piece that'll lay basically on the outside of the sear, and it'll be hinged in here somewhere. And so what'll happen is when the sear releases, the intercepting sear will drop down out of the way and allow this to rotate. But if only the sear releases and not the intercepting sear, it'll catch and prevent the tumbler from rotating. So basically, if your trigger piece were down here, and you pull the trigger, it moves both pieces, clearance happens, the sear disengages from the full cock notch, allowing the tumbler to rotate. But if recoil, or bouncing it or jostling it or dropping it, knocks the sear loose from the full cock notch, the intercepting sear is still engaged and prevents the tumbler from rotating. So that's going to be the intercepting sear. Since I'm going to be making several of these locks, two for the double rifle, and then I've got a pistol build that's going to need to lock this shape as well, what I've done is I've cut three pieces of just plain old 1018, and the reason I'm not using 8620 or anything on this is 1018 will still color case beautifully to match the rest of the action. But this lock plate isn't critical. It's not a critical part that's going to take a lot of stress or anything else. It just contains the parts that function to make the lock work. So it doesn't have to be out of 8620 or anything special. It can be out of just plain old 1018, and it'll color case up and match really well, so that's not going to be a problem. So what I've done is, since I've got to make three of these, and they all need to look the same and match, is I cut three pieces of plate, and then I took my TIG and just washed over it and tied the ends together. I didn't even use any filler rod to do this. I just washed them in and tied them together at both ends, and that keeps everything held together nicely in alignment. And then what I'll do is I will put my template on here, I will scribe around it, and then I'll probably come in and punch it so that I don't lose my scribe lines while I'm removing material. And then I'll come in and I'll just cut it out basically. And then as long as I don't cut clean through the face and the back, if I leave the radius and the face here till the very last thing when I'm ready to separate them, I can go ahead and do some of my drilling operations while it's still all stacked together. so I know that everything will be the same from each lock. So that's how we're going to start this, is scribing some lines on here and then cutting it out, and then I'll start drilling my holes where they belong. So the first step was to hack off the bulk of this extra metal up here, and then I used my 12-inch disc grinder to shape the curved contour, and it works pretty good that way if you can get it down to close to the line and then just use a big grinder to take it off. If not, it can always be done with files or hand grinders or any number of other ways. I just happen to have a big grinder, 12-inch, that removes metal pretty fast. But the stack's still welded together at both ends, so that's holding it nicely in shape. Now what I'll do is I'll come in and I'll saw these parts off as kind of close as I can get them without getting too accurate, and then I'll come in and I'll use a oscillating sander to take in the internal curve and probably do a little of the external curve with it, the concave and the convex part, and then up here I'll probably finish this out with file work up here. You'll notice when I laid this out, I used a piece of metal that was fairly close to the overall size that I was going to need, so I didn't have a ton of stuff to remove. And you'll also notice that I brought it down to where I made the parts that are going to be the most difficult to work basically as shallow as I could make them. That way it'll save me time in removing material. You know, I'll leave this section back here until last, along with this section up here. So basically the ends will be done last after I do some drill work and stuff. But I'll be able to take off all of this section here, doing some saw work, and then using the oscillating spindle sander, and then there's a little bit of hand work to clean up the last of it. So pretty straightforward. I'll show you what it looks like once I get some of this other stuff removed. So now that I have everything pretty closely shaped, and all that's left is just the ends that are still holding the stack together, and you can follow, it follows the template pretty closely. Just what I wanted. So the next step is to do some layout work, and what you'll notice here is I can basically use the lock to get everything fairly close. The original lock plate will give me all of my holes, and I can use edge finders to actually locate edges and then move to center on each one of these. Right now, because none of these plates are shaped with the Bosch or the offset or the bolster or the offset or any of that in it, what I can do is, knowing that this is the top edge, I can make all of these holes in all stacks at the same time, and then I can come in and, depending on whether it's left-handed or right-handed, remove the amount of material that needs to be removed to make it a left or a right lock. So that's the easy way to do it, is to use the lock plate, do some layouts, then take some measurements to ensure that you find actual true center on this stuff, and then clamp it in the mill drill and drill some holes through it. On this one here particularly, you know, all of these are threaded holes, but this one here for the tumbler, what I'll do is I'll actually drill it undersized, and then I have a reamer that's the right diameter, and I'll ream that hole through as a final cut on it. So that's how that'll be done, and I'll get on with that, and I'll show you how it looks after the holes are put in it. So I drilled all the holes here, reamed the tumbler shaft hole, and wanted to show you this. In a standard L&R lock, the way they come, I don't know if you'll be able to see this really well or not, but I'll try and get it in here. What you'll notice is that, like, this surface here is nice and shiny and ground, and there's a couple other surfaces that are ground and polished, but overall most of these parts on an L&R lock are as cast, basically. So none of the shoulders are polished, none of the shafts are polished, the tumbler shaft isn't polished, and you'll notice that when I stick it in here, it's really kind of a low tolerance fit. I mean, it doesn't really, it's got a little slop and play in it, and it doesn't really snug in and rotate really smoothly. I don't know, it's hard to get this thing to focus on that without going to a micro setting, or macro setting, I mean. But anyways, you get the idea that there's a bit of slop in these from the factory, or from, you know, L&R's manufacturing. And so when I reamed this, I reamed it just a few thousandths undersized. You'll notice that this one won't quite seat down in there like it does on that other lock. And what I'm going to do is I'll take some lapping compound, and I'll smear some lapping compound on this, and I'll hand lap this until it's a precision fit in there to where it has just enough slack in it to rotate really smoothly. And that way it's got the full amount of shoulder on it, full amount of bearing surface, it's got the most precision fit I can make it. And when I harden this lock plate up and color case it, it ought to rotate like greased glass in there. But right now it's a little tight, a little snug, and I will hand lap that in to make it a real precision fit. These other holes are tapped, except for this one, which is this mainspring hole. And this mainspring hole is drilled for a precision fit on it too. So, anyways, just wanted to show you that so that you can see that it's the difference between a lock that works and functions good and a lock that's truly a precision fit and really a hand-fitted, craftsman-made lock. So, some of the lock companies, I guess I'll go on a little rant here for just a second. Some of the lock companies are really, really good about their fits of their parts in their locks. Chambers, their flint locks are some of the finest I've ever seen made. Their fits and tolerances are very good. They work like grease glass. They're a very fast lock. R.E. Davis is another good one. Their locks are pretty well made. And L&R is the other third, probably major company in this country, and a lot of their tolerances on L&R stuff was a little loose, actually. And so I, just from opinion's sake, and just from my point of view, if I can buy a Chambers in the same style and period and time frame as I would an L&R, I'll take the Chambers every time because it saves me a lot of work when I'm actually building the stuff and making the lock. In this case, though, nobody makes this style of lock plate in this type of lock with the safety features I'm going to put in it, so it didn't really matter. I had to make it anyways. Buying L&R parts just saves me the time of having to machine and manufacture each individual part, plus make the springs. I'm able to, strip their parts out, polish them up, clean them up real good, bring them into real tight tolerances, and turn their parts into a real good high-end lock. So for me, it's just a time saver to gut one of their locks and redo it. But anytime I can buy a lock that's really high quality and precision made, like Chambers or Davis, I'll take the Chambers every time. So none of these holes are tapped yet, and the reason I didn't tap them yet is because no point in trying to run a tap down through this big thick block and running a risk of it getting jammed in between the layers or anything and breaking a tap off. And the other part is I'm going to machine the thickness down, basically just like the original lock plate, to where it's same thickness here and thicker here, and so it'll be a lot easier to tap this thin material than it would be to tap the whole width of a single lock or all three locks. So I'll save tapping this until after I have the machining done to bring it down to thickness. And then the next step, what I'm going to do next on this is go ahead and separate these. I'm going to finish rounding out this end, which will take that weld off of there. And then I'm going to lay it out for length where I want my piece to end up here in front. I need a little more length than what I have here because of the way it's going to fit into the corner of the action, and so I'll leave a little extra on here and I'll go ahead and cut it off, and that'll take care of the welds I made on this end, and I'll have 3 separate locks that I'll be able to lay down flat and start machining them down to proper thickness. So as you can see, ready to start machining these down to thickness, and what I've done is I've laid these out. It's 2 lefts and a right, so I'm going to machine the inside material out. And what I did was, because as this gets cut and it gets thinner, it's going to want to tend to warp. So to prevent it from doing that, I did a really quick and ugly solder job and soldered it down to a pretty thick piece of plate steel here. And that'll hold it down nice and tight, so that when it's cutting back and forth and it starts to get thinner, it doesn't warp up away from there and cause an uneven cut, hopefully. You can see I just laid a scribe line on there. That's roughly where I'm going to cut to. When I get close, I'll measure it on the mill and stuff and actually bring it down to where it needs to be, but that's close enough. And then there's a scribe line back here, and this is one of the changes I'm going to make, and I do this on a lot of these kind of locks, is I leave this back thick just like the front is. And the reason I do that is instead of putting a screw like this, a wood screw in, which is what this lock's designed for, what I'll actually do is I'll drill through and through from the left lock to the right lock, or vice versa, and I'll tap one side and countersink the other, and then there'll be one screw that pulls in and sandwiches the tail of both locks into the wood. So that extra bit of material there gives me room to countersink, and it gives me room to get some extra threads in there. So that's why I leave that end piece on there. So you can see that I got them machined down. All three of them have the same inset in them, and they're the right thickness now to work with the parts that I've got. And you can see that I've unsoldered them from the plate that I had them attached to for the machining. Now what I'm going to do is I'm going to clean up all this solder on the inside and outside and all these edges and everything. I'll clean up the solder. I'll clean up any machining edges that are left rough. I'll clean out all the holes, and then I'll go ahead and tap these holes. I'll lap the tumbler hole and get the tumblers fitting real good, and then I'm going to reassemble everything on these locks and make sure that everything functions as a normal lock before I start making modifications for safety and whatnot. The reason I'm going to do it that way is because if anything's off or anything's wrong, you know, depending on how bad it is or whatever, I may be able to just fix it, or if anything is badly off, then I'll just scrap these and make a new set of plates and redo everything. But it'll save me time instead of going through all the effort of making the safeties and everything and getting it all built and then put it together and it doesn't fit. So I'll go ahead and clean these up after they cool and reassemble them, and then I'll see if everything works properly. If it all does, then I'll move on to the next step of making the safeties for them. So here's the first of the three locks put back together. This is the one I'm going to use for that extra project, and you can see it really enhanced the shape of the lock plate, gave it a nice smooth curve, and so it'll match a nice pistol grip radius that way and really blend in better in the stock and have an overall better appearance. This one is basically done. I won't have to add the safeties or anything to this because this is not going on a double rifle project. It's actually going on a pistol, and so it'll be a real simple setup that's basically finished the way it is. I just need to polish out the rest of these parts and polish out the hammer, and it's basically done. But it functions just like it should, from half cock to full cock and then to release. So that's the way that one's going to look. One of the reasons I put this one together before I messed with the other two is because I wanted to look at clearances and stuff, and I was kind of concerned about this when I was first setting it up and thinking about where I'm going to put the stocking safety. And as I mentioned earlier, I had wanted to put the stocking safety in front of it here, but you'll notice that in the full hammered down position, in the fired position, there's not very much room up here. And so on the double rifle, where the breeches will stick out past it, I don't think a guy's going to be able to get his hand in there and work it really smooth and cleanly. It'll be kind of a cramped space. So what I'm going to do is, on the other two locks, I'm going to put the stocking safety behind the hammer, and then it'll have plenty of room back here. A guy will be able to get his hand in and snap it forward or back and make it work properly. So a little change of plan, but nothing that really changes anything overall. It just means that the stocking safety will be to the rear instead of to the front. So, but that's how these work. Other than polishing, this one is done. So I'll get on to the other two and get them put back together, make sure everything's going to function as well, but they should. All the holes should be in the same alignment as this one, so everything should function on the other two. Once I know that they're going to function just fine and everything's going to work properly, then I'll start in on putting the stocking safety in and the intercepting sear. So here's the first step in making the stocking safeties, and obviously you can tell by the size of my fingers I've got my camera zoomed in quite a bit. What I did was I took a piece of 1/4" key stock, and I came in and I machined these two little protrusions. I just removed metal all the way around them, and you can see they stick up about 30 thousandths. What that's going to do is that is going to set into a groove that I'm going to machine in the lock plate. And that'll be like a key and a keyway basically when I'm done, so that it has something to slide back and forth in the lock plate. And then I drilled it and tapped it for screws. And there'll be a channel on the inside of the lock machined in. These screws are considerably long right at the minute. These are going to have to be trimmed down to the exact length so that they bottom out and leave slack, but I'll machine a groove in the inside of the lock that these will recess down into, and basically what it'll create is it'll create a little sandwich between the shoulder of the screw and the shoulder of the safety, and give it a groove to slide in, and it'll slide back and forth in a kind of a trapped position that way. And this also, working from this direction, machining this off and drilling and tapping these first. The other thing that this does is what I'll do to do the rest of the machining to shape the outside of the lock, I will take a piece of scrap metal, I'll drill a couple holes in it and suck this down into a piece of metal. Then I'll be able to put the whole thing back in my mill and do the rest of my machining. So doing it this way in these steps allows me to be able to put a piece on here and clamp onto it real solid to do the rest of my machine work. So that's the first step in making the safeties. So here's the two safeties made out of the one piece. What I did was I machined the center radius, and then I came in and machined both ends down to their thickness and made a nice little radius, and then I just cut it in half with a hacksaw. And what I'll do is take the two screws out, clean up the ends where my hacksaw cut's not very straight, and the safeties will basically be made. The only thing I'll have to do to these is polish them up a little bit, and then of course I'll have to either checker or engrave or scribe some kind of gripped texture on this section here on each one, so that the guy can get a good feel for it and make the safety work good just by feel. So, but other than that, pretty easy way to make those. Make it as one piece, then cut it in two, and be done with it. So the next part is to strip the locks back down. Since I assembled them and made sure they were functional, the next part's to strip them down and do some layout and machine the grooves in the lock plate that'll accept the stocking safeties. So I've got this one lock stocking safety done and installed on it. I've got this one all fitted and ready to go. I just wanted to leave it apart long enough to show you how it worked. It goes to half cock, then it goes to full cock, and then when it's in full cock, the stocking safety will slide forward, and it stays there with a little detent system. It also stays in the off safe position by a detent, and I wanted to show you all those little parts and show you how it looked before I moved on here. So what I've got is I've got the hammer, and this would be the outside piece on the stocking safety, and I don't know if you can see it, there's a couple little detent holes in there, and the way it works is it just slides forward and engages the notch that I machined in the back of the hammer, and so it gives it a real positive engagement, you know, makes it so that there's a mechanical lock so that the hammer can't drop unless the stocking safety's off. And the way it's fitted into the lock is it's recessed on this side to match the recess on the stocking safety. And then when you flip it over, it's also recessed on this side so that the screw head is below flush, so it doesn't catch any of the springs or any of the moving parts inside. And the way this works to keep it from sliding smoothly is that the screw bottoms out and stops just short of being able to actually pinch both sides together. So it bottoms out, stops, and leaves just enough slack in it to give it a real clean movement. So that's how it all goes together and how it functions mechanically. And you can see there's a little hole there with a spring, and when I turned it upside down, my detent rolled out right there. So I will put this one together, and then I'll move on to working on the intercepting sears. But that's going to wait for next week. This is the end of my week, and it took a lot longer to build the jigs to get these things all lined up and make these cuts than I thought it was going to, particularly the jig to hold the hammer in position to make that little notch in my mill. So it took me quite a bit longer to make the tooling, the jigs and setup for my tooling than I expected. So the intercepting sears will have to wait till next week, and I'll start on them Monday and get an intercepting sear built on the inside of the lock up here. So it'll be another piece like I described earlier, and I'll get on that Monday morning.